Good day, everyone. Welcome to Calcumind. Today, we are going to be looking at statistics past questions. For our first question, it says, succinctly explain the two main methods of assigning probability. The second one says, a three-member committee is consisted of 3 girls and 3 boys from the Faculty of Engineering. If the selection is random, 1. List out the sample space. 2. Calculate the probability that more girls than boys shall be selected. And 3. What is the probability that a particular girl will be selected? So let's dive right into it. We'll be looking at the first question, which says succinctly explain the two types or the two main types of probability. Now, the two main types of probability are one, the classical or theoretical probability, and two, the empirical or experimental probability. Now, for the first method of assigning probability, which is the classical or the theoretical method of probability, in this method, we assign probability based on an assumption that each outcome is equally as likely to occur. So, for example, if you were to toss a fair coin, you'd have that the possibility of getting an outcome of heads is 1/2, which is equally as likely as the possibility of getting a tail as an outcome, which is also 1/2. Now, the classical or the theoretical probability is a method used under equal conditions, or under the condition that everything is happening the way it is supposed to happen. That is why it's called theoretical, because in a normal circumstance, you wouldn't have each outcome being equally as likely as the other. That's why the classical method is operating under the assumption that all outcomes are equally as likely. Now, under the classical method, we have that the probability of an event is equal to the number of favorable outcomes all divided by the total number of possible outcomes. So, for example, if you are asked to find the probability of finding a head when a fair coin is tossed, you'd have that the probability of that event occurring is equal to the number of favorable outcomes, which in this case is 1, divided by the total number of possible outcomes, which is 2. Because we have only 2 possible outcomes when tossing a fair coin. You either get head or you get tail. Hence, the probability of this event occurring, according to the classical method, is equal to 1/2. Now, the next method is the empirical or the experimental method. Now, whereas the classical method operates under the assumption that each outcome is equally as likely to occur, the empirical or the experimental method operates under actual observation noticed or taken during experimentation. So, in the classical method, we are assuming that every outcome happens in equal chances. Whereas in the experimental method, we take observation based on experiments being conducted. So we have that the formula for the experimental method, being the probability of the event, is equal to the number of times the event occurs all divided by the total number of trials carried out. So for example, if we were to have a question that says that a fair coin, or rather a coin in general, because under the empirical method, the method of finding your probability is not necessarily fair. So we have that a coin is being tossed 57 times. And in those 57 times, the number of times heads show up is 20 times. Now, under the empirical method, the probability of getting heads, which is the probability of the event E, is equal to 20, which is the number of times we get the outcome we are looking for, which is the event that occurs, which is finding head, all divided by the total number of trials, 57, because the coin is tossed 57 times. Hence, under the classical method of probability, the probability of this event occurring, which is probability of getting head when you toss a coin, is equal to 20 over 57, based on actual observation noticed or taken down during the experimentation. Now we are asked to list out the sample space for a 3-member committee, which is selected from 3 boys and 3 girls. So first of all, it is important to know where we are carrying the selection from. So we have 3 girls, which we are going to denote as G1, G2, and G3, and also 3 boys, which will be denoted as B1, B2, and B3. Now we are being asked to list out the sample space for this 3-member committee. So now what we are going to do is that we are going to separate each of these members into groups of 2s that we are going to vary alongside the other group. So what we are going to do, we are going to dive right into it. We have G1 and G2, G1 and G3, G2 and G3, B1 and B2, B2 and B3, and finally B1 and B3. So we have that the first possibility for getting as an outcome is G1 and G2. We are going to start with this set, G1 and G2. Then we vary it along the number of boys that we are selecting. So we have G1, G2, B1. Our next set is G1, G2, B2. The next is G1, G2, B3. Now that we are done with G1 and G2, and we have cycled it alongside this, we are going to pick the next one, which is G1 and G3. So we have G1, G3, B1. We repeat the process. G1, G3, B2, and G1, G3, B3. After that, we have the next one, G2 and G3. So we have G2, G3, B1, G2, G3, B2. Since we are done with the groups for the girls, we are going to move on for the boys. So we'll take B1, B2, B2, B3, and B1, B3, and then cycle it along G1, G2, and G3. So for the first set, we have B1, B2, G1, B1, B2, G2, and B1, B2, G3. Since we are done with B1, B2, we go on to the next, which is B2, B3. We repeat the process. B2, B3, G1, B2, B3, G2, and B2, B3, G3. Now, since we are done with B2, B3, we go on to the last one, which is B1, B3. And we have B1, B3, G1, B1, B3, G2, and B1, B3, G3. Now, this sample space is each possible outcome for organizing a 3-member committee picked out of 3 boys and 3 girls. Now that we have outlined each of the possible combinations having at least 1 girl or 1 boy in the group, it is now important to add the last combinations which have all boys and all girls. So we also include B1, B2, and B3, and G1, G2, and G3. So all of this is the sample space.
G3 is 2.
Sorry. So all of this is the sample space for the possibility of selecting a 3-member committee out of 3 boys and 3 girls. Okay. So this first question told us to outline the sample space, and the second question is telling us to calculate the probability that more girls than boys will be selected. Now, what this means is from the sample space, how many of the events outlined there have more girls than boys in them? For example, we had G1, G2, and B1 being a possible outcome. This has, for this 3-member committee, this had 2 girls and 1 boy. This is having more girls than boys being selected for the 3-member committee. We also had G1, G2, and G3 as a possible outcome. So this had 3 girls being selected for the 3-member committee. Now, what the question is asking us is, out of the entire sample space listed out in question 1, how many of them have 3 girls or 2 girls and 1 boy? What is the probability of selecting these sample points with either 3 girls completely filling up the 3-member committee, or 2 girls and 1 boy completely forming the 3-member committee? So we can either go back to the sample space and count all of this, because we know that for classical probability, the probability of an event is equal to the number of favorable outcomes divided by the total number of possible outcomes. Now, the number of favorable outcomes for this is how many of the sample points outlined in the sample space have either 3 girls or 2 girls and just 1 boy. So you either count all of that and impute it as your number of favorable outcomes, then divide it by the total number of possible outcomes, which is the total number of sample points in that sample space. Now, if you had counted it when we outlined the sample space, you would see that the total number of sample points there number to 20. So you'd find the number of favorable outcomes, which is how many of the sample points having 2 girls and 1 boy, or 3 girls completely, and you would add them up, then divide by the total number of possible outcomes, which is the entire sample space. Now, if you were to add this up and divide, for this, if you count it in the sample space we outlined, you'll find out that the number of sample points with 2 girls and 1 boy is 9, while with 3 girls alone and 0 boys is 1. Then you divide by the total number of possible outcomes, which is the total sample space, which if you count, will give you 20, which is equal to 10 over 20, which is equal to 1 over 2. So this is the probability of getting a 3-member committee with more girls than boys.
Continue.
So the second method, which is combination. Now, combination is using a formula to find out the total number of ways we can have a list by selecting points out of what is available. So the formula for combination is n combination arrow, where n is the total number of objects and r is the object you are selecting from. So now this is equal to n factorial divided by n minus r factorial r factorial. Now you may be wondering what a factorial is. So if we were to have, for example, 5 factorial, this would be equal to 5 times 4 times 3 times 2 times 1. Or instead of 5 factorial, you could write 5 multiplied by 4 factorial, which would be equal to 5 times 4 factorial would now be what is remaining from here. 4 times 3 times 2 times 1. So that's how it goes. So if we are to find the probability of having more girls than boys selected for the 3-member committee, you'd have for your sample points that you'd have either 3 girls and 0 boys, as we earlier stated, or you'd have 2 girls and 1 boy. So if you had 3 girls and 0 boys, you have 3 plus 0, which is 3, which fills out the committee entirely, or you'd have 2 girls and 1 boy, which is equal to 3, which fills out the committee entirely. So instead of going to count the total number of sample points that have 3 girls completely, or 2 girls and 1 boy, you could just take the combination of this and add it to the combination of this. Because if you remember, whenever we say or in probability, it means addition. So if you have either this or this as your answer, you have to take the combination of this and add it with the combination of this. So what this means is that combination, what are we selecting? We are selecting 0 boys out of 3 because it's a 3-member committee. So you select 0 boys out of 3 and you multiply it with selecting 3 girls out of 3 for the 3-member committee. Because in order to select 3 girls for the 3-member committee, it means you're selecting 0 boys for the 3-member committee. So we multiply rather. Then you add this with selecting 2 girls for the 3-member committee multiplied by selecting 1 boy for the 3-member committee. Because R is what you're selecting and N is the total you have to select from. So since we have a 3-member committee, that's the total space that we have. And what we are selecting is 0 boys, 3 girls, 2 girls, 1 boy. Now, another important point to note is that we are using combination because this is a random selection. And for random selections, it doesn't matter how it is arranged. So you could have G1, G2, and also have G2, G1 in one sample point, and it wouldn't matter, it wouldn't affect it because it's a random selection. The way it is arranged doesn't matter. That's why we are using combination to outline this. So let's compute this and get our answer. So this is 3 combination 0 from what I showed you before from the formula. This would be 3 factorial divided by 3 minus 0 factorial, 0 factorial, multiplied by 3 factorial divided by 3 minus 3 factorial, 3 factorial, put this in a bracket, plus 3 factorial divided by 3 minus 2 factorial, 2 factorial, multiplied by 3 factorial divided by 3 minus 1 factorial, 1 factorial. We put this in a bracket also. So this is going to give us 3 factorial, like I said earlier, divided by 3 minus 0 is 3 factorial. So this is 3 factorial, 0 factorial, multiplied by 3 factorial divided by 3 minus 3 is 0. So we have 0 factorial, 3 factorial. Put this in a bracket once again and add with 3 factorial. 3 minus 2 is 1 factorial. 2 factorial multiplied by 3 factorial. 3 minus 1 is 2 factorial, 1 factorial. So we have that this is equal to 3 factorial over 3 factorial. This cancels out to give us 1 over 0 factorial is 1. It's important to note it. Just note it somewhere that 0 factorial is equal to 1. So we have that this is 1 multiplied by 3 factorial, cancels out 3 factorial, we have 1. 0 factorial is 1 once again, plus 3 factorial, like I stated earlier, is 3 multiplied by 2 factorial divided by 1 factorial is 1 multiplied by 2 factorial, because 3 factorial is 3 times 2 times 1. So we can just take 3 factorial as 3 multiplied by 2 factorial, which is 2 times 1, so that these 2 can cancel out. And then we multiply it, we have 3 times 2 factorial once again, divided by 2 factorial times 1, because 1 factorial is 1. So we cancel this out, this is 1. We cancel this out, this is 1. So this is equal to 1 plus 3 times 3. 1 plus 3 times 3, which is equal to 1 plus 9, which is 10. So what we've calculated is the total number of favorable outcomes, meaning that all the sample points in our sample space that we listed out earlier, we have 10 sample points that either have 2 girls and 1 boy, which gave us this 9. So 9 sample points have 2 girls and 1 boy, and 1 sample point has 3 girls altogether, or 3 girls and 0 boys. So the favorable outcome, which is the probability of what we are looking for, or the total number of sample points with more girls than boys, is 10. So we have 10 sample points with more girls than boys. So to calculate the probability of getting more girls than boys, let's call that the probability of G, is equal to the total number of favorable outcomes, which is 10, divided by the total number of possible outcomes, which is the size of our sample space, which if you were to count from the earlier part of this video, you would see that it numbers to 20. So this is 10 over 20, which is equal to 1 over 2. The same as what we got from simply counting it out. So if you didn't have the time to outline the sample space, you could just use your combination, get the total number of favorable outcomes, then divide by the total number of possible outcomes. Now our third question rather, which is 2ii, tells us to find the probability that a particular girl will be chosen. So once again, we look at the sample points that we are picking from to form the 3-member committee. So we have G1, G2, and G3, and also B1, B2, and B3 to form a 3-member committee. So they say, what is the possibility, or the probability rather, that a particular girl will be chosen? So let's say that particular girl that will be chosen is G1. If G1 is chosen, it means that out of the 3 spaces for the 3-member committee, 1 space is already taken by G1, meaning that what is left of the sample points is G2, G3, B1, B2, and B3. So we have 5 sample points left. 5 sample points left. So to share these 2 spaces for the remaining 2 members. So we use combination once again to outline all the possible sample points that you would have with G1 chosen and G2, G3, B1, B2, and B3, filling in the remaining two spots. So we have that you take the combination. What are we trying to choose? We are trying to choose 2 committee members out of 5 total members or sample points that we have. So we evaluate this. We have that this is 5 factorial divided by 5 minus 2 factorial, 2 factorial, which is equal to 5 factorial all over 3 factorial, 2 factorial, which is equal to 5 times 4 times 3 factorial all over 2 factorial times 2 times 1. So we have, this is 3 factorial. We have this cancelling out with this to give us 10. So we've gotten the favorable outcomes, which are the total number of sample points having more girls. We've gotten the favorable outcomes, which are the total number of sample points having more girls than boys. And we said that it's equal to 10. So we remember that the probability of getting more girls than boys is equal to total number of favorable outcomes all over the total number of possible outcomes. So we have that the total number of favorable outcomes, as we calculated it, is 10 divided by the total number of possible outcomes, which is the entire sample space, and we got that to be 20. So we have that the probability of picking a 3-member committee out of 3 boys and 3 girls is equal to 10 over 20, which is 1 over 2. Thank you very much. I hope you enjoyed this lecture. Please do well to like, share, and subscribe. And if you have any question, please comment in the comment section below. Thank you.